One of the key reasons that we're interested in geometric optics is we want to know how people see and to help people see better. And so we'll talk a little bit here in this short video about both microscopes and telescopes, but also corrective lenses. How do lenses change the way that we actually see the world around us? So how do microscopes work? Well, we can use the same kind of language we used for lenses and mirrors. Sometimes they use both of those. Oftentimes they'll just use lenses. Uh, Telescopes sometimes just use their major gathering is mirrors. Um, but basically, it's a chain reaction sort of thing in which a first lens creates an image, and then that image becomes the object for a second lens. And so we can actually analyze a microscope or a telescope by looking at one lens and figuring out how much it's magnified or inverted the image, and then looking at what happens as it goes through the second lens. And we can write the magnification like this. It's just a product of the different lenses, right? This is the magnification caused by the first lens. This is the magnification caused by the second lens, and this is M total. So let's look at this example here. We have an object, which is our arrow, okay? It's outside of focal length of a converging lens. So this is our case one that we were talking about. And in case one, you get an inverted real image, okay? So the lens or the rays come through here, they create this image here. And then we have a second lens, right? This is our eyepiece lens. And here we have our second case, right? A converging lens, but our object, which this now the first image, is inside our focal length of the second lens. And so this acts as a magnifying glass, essentially. And so if we ray trace this, and we want to figure out what's hitting this person's eye, we're going to get a virtual image here that is magnified. Okay, and so this is not inverted because remember this one was already inverted, but we get a much larger image right here. Okay, and we'll close with some thoughts on eyeballs. Eyeballs are really cool, and so are glasses. Um, but the human eye uses a lens, just like in the case one, right? So it's a converging lens, and the objects are almost always outside of our focal point. We know that that is a projected real image, right? That it's inverted. So you can see that inversion with this little button there, although a button is a bad thing to see an inversion with. We can change the focal length of our eye, right? In other words, and when we do that, we're changing the power of our magnification, right? So this one image here, this is an object that's far away, right? Parallel rays coming in. We have a small power lens that focuses the image on the back of our eye. And we want to make the distance between the lens and the retina, that is this distance here, we want to make that equal to di. So we can manipulate that equation, the lens equation, 1 over do plus 1 over di equals 1 over f. If we know what do is, right, that's how far the object is away, we can change f, the power of our lens, in order to make di equal to whatever, this 2 centimeters between our lens and our retina. We generally like to see things far away because that means we have a smaller focus or smaller power to our lens. It doesn't require as much energy from our eye. We don't have to change the shape of our lens much. As we get closer to an object, we have to strain a little bit in order to increase the power of that lens and to shorten its focal length, right? So if we want to see an object here, we want to keep that object outside of our focal length, and so our focal length gets shorter and shorter. So that's how an eye works. It's basically the same thing we've been talking about with lenses. It's just that the lens is able to change shape to accommodate uh, objects at different distances. So what do we do when we put on a pair of glasses? Well, our eyes get tired as we get older, um, and as we read more and all sorts of different stuff. And so we have to change the way that objects, that rays are entering the eye to help our eye out. That's basically what a lens is. So let's look at a nearsighted eye. This results from a lens that's too powerful, right? So this is our nearsighted eye right here. The rays come in, the lens is too powerful, and the focal distance and DI are too short. Okay, so what do we do? Well, if we don't want to change the lens itself, okay, and do surgery, we can put a diverging lens here, uh, and the rays then start to diverge as they go into the eye, which requires then a more powerful lens. It's sort of like making this object, if we follow these lines, it's making the object closer to us, right, or making it seem closer to us, to the eye. And then the eye, which is too powerful, is able to work on those diverging rays to get them to focus in the right place. So that's a nearsighted diverging lens. Um, let's see, for farsightedness, we use a converging lens. So farsightedness, that is when we can see far but have trouble seeing near, our lens is not powerful enough, okay? And so the converging lens helps to converge those rays, right? So if this close object is here, it requires a powerful lens, but our uncorrected rays end up focusing back here. So we correct that with a converging lens, and that then allows us to focus our image in the right place. So in both cases, essentially what's happening is that our natural lens, our eye lens, is either too powerful or too weak to handle a particular kind of ray. And then our glasses change the rays that are coming into our eyes to make it easier for our eye to handle. And that's how our eye works, and glasses. Pretty cool.